right, in previous lessons we've been working with fractions and we worked with multiplying and dividing fractions. In this unit we're going to look at adding and subtracting fractions, and most of you remember that in order to add and subtract fractions you have to have common denominator. A least common denominator is a special case of something called the least common multiple of numbers. All right, to find the least common multiple, we're going to look at two ways. One of them, method number one, has to do with actually getting a list of common multiples. So let's take a look at finding the least common multiple of 6 and 12. Least common multiple. Well, we had a lesson with multiples earlier, and if you took 6 and you looked at its multiples, 6 times 1 is 6, 6 times 2 is 12, 6 times 3 is 18, 6 times 4 is 24, and I really don't know when I start this process how far I'm going to need to go. Those are the multiples of 6. 12. 12 times 1 is 12, 12 times 2 is 24, 12 times 3 is 36, 12 times 4 is 48. Once again, right now I'm not quite sure how many I need. I need to compare my two lists of multiples, and I want to find the common or the shared common multiple. All right, I think you can see that 12 is a multiple of 6, and 12 of course is a multiple of itself. The least common multiple of these two numbers is 12. It is a common or shared multiple. Something that these notes encourage you to do is determine whether the largest number is a multiple of the other. So in other words, we could have looked at 12 and said, is 12 a multiple of 6? Which could be said, does 6 go into 12 evenly? And if it does, that's our least common multiple. All right, so look at the big number and see if it is. But what if it's not? Let's take a look at trying to find the least common multiple of 12 and 8. All right, let's start with the small one in this case. Let's look at 8. The multiples of 8, 8 times 1 is 8, 8 times 2 is 16, 8 times 3 is 24, 8 times 4 is 32, and once again I'm not quite sure if I've written enough, but I've got the first four multiples of 8. Let's look at 12. 12 times 1 is 12, 12 times 2 is 24. I can stop because I have now gotten a common multiple, and it's the least or the smallest or the first common multiple. The least common multiple of these two numbers is 24. I really could have avoided writing this list down and just said, let me look at the multiples of 12 and I will see if 8 is a factor of them. I write down 12. Does 8 go into 12? No. All right, 2 times 12 is 24. Does 8 go into 24? Yes. So I can just go to the larger number and start going through its multiples, asking if the smaller number goes into it. All right. The second method is to use prime factorizations. Now, I have a shortcut method for using this. I will tell you, let's do it the long way and then I'm going to show you the shortcut. Let's suppose that we're trying to find the least common multiple of 20 and 30. All right. Well, if I'm going to use this method called prime factorization, I have to get the prime factorization. I think I'll call that 2 times 10. That's a prime. Because remember, primes have no other factors other than themselves and 1. 10 is not prime, but I can factor it. It's 2 times 5, and those are primes. I have 2 times 2 times 5. Any common multiple of these two numbers must contain a 2, and a 5. Let's look at 30. I'll say it's 3 times 10. All right. All right. 10, it's 3 times 10, and there's my prime. 10, it's not a prime number, but it has prime factors of 2 and 5. So the prime factorization of 30 is 2 times 3 times 5. Now, you have to take these two different prime factorizations and figure out what the least common multiple is from those. And what you have to do is look at it and say, okay, I have to have a 2 because either one of them has a 2, you have to have a 2. But if this one has 2 2's, then you must take them both. So if you have any repeated factors, then you have to use the one that has more. So I needed the 2 2's instead of the 1 2. I also need a 3, and I also need a 5. So it's one of every different kind of factor, 2's, 3's, and 5's, and the greatest quantity that's in either one. Don't put 2, 2, and 2. You just need the one that has the double 2. If you multiply those, 2 times 2 is 4, 4 times 3 is 12, and 12 times 5 is 60. The least common multiple is 60. But let me show you a shortcut that might really, really help. Take the two numbers that you're trying to find the least common multiple of, write them down side by side, and do an upside down division box. This is going to seem strange, but it is a very cool shortcut. Now, you can only use prime numbers. The smallest prime number is 2. So will 2 go into either one of these? Yes. And you're going to write the answer below. This is easier to go downwards. 2 goes into 20 10 times. 2 goes into 30. It goes 15 times. Will 2 work again? It doesn't have to go in both of them, but will it go in either of them? Yes. 2 goes into 10 5 times. It does not go into 15, so I just bring the 15 down. Does 2 work anymore in either one? No. Does 3 go into either one? Yes. It doesn't go into 5, so bring the 5 down, but it goes into 15 5 times. 3 doesn't work anymore, but I think it's pretty obvious 5 does. And these numbers have to be primes. It goes in there once, and it goes in there once. When you get all ones down here, you're done. And your least common multiple is the product of these. 2 times 2 times 3 times 5, which is 60. And that's the same thing I got over here. You divide by primes, and you divide if it will go into either one of them. It doesn't have to go into both. All right, so now let's look at our problems, and we'll decide if we can. And where did problem number 1 go? It looks like I lost it. Okay, I'll start with number 2. It says find the least common multiple of this set of numbers. All right. All right, one way, if I use method number 1, I have 14 and 4 go to the big. Let's look. Let's go to the big number, 14. Let's look at its multiples. 14 times 1 is 14. Does 4 divide into 14 evenly? The answer is no. Next multiple, 14 times 2 is 28. Does 4 go into 28? The answer is yes. The least common multiple is 28. I got that by just looking at multiples of 14. This is 14 times 1, 14 times 2. I might have had to do 14 times 3. And I'm checking to see if the other number, the smaller number, goes into them. When I find one that does, I've got the least common multiple. Now let's use method 2. Method 2 is prime factors. So I've got 14 and 4, and I'm going to divide by primes. Remember that 2 is your first prime. 2 does go into 14 7 times. 2 does go into 4 2 times. Can I use 2 again? Well, now 2 doesn't go into 7, but it goes into 2, which means I get to use it. Bring down the 7. 2 goes into 2 1 time. 3 isn't going to work, 5 isn't going to work, but 7 is a prime. 7 goes into 7 one time, bring down the 1. All 1s mean you're done, and the least common multiple is 2 times 2 times 7. 2 times 2 is 4, and 4 times 7 is 28. So it did not matter whether I used the listing of the multiples or I used prime factors, I still got that both 14 and 4 will go into 28. Let's look at another one. We may have done this problem as an example. If I use method 1, then I take 12 and I start looking at its multiples. 12 times 1 is 12. Does 8 go into 12? No. 12 times 2 is 24. Does 8 go into 24? Yes. Then that's my least common multiple. My method 2, and you certainly don't have to do them both, you pick the one you want. We're looking at 8 and 12, and we're going to divide by prime numbers. And in case you need to review, prime numbers are 2, 3, 5, 7, 9's not one, but 11 is, 13 is, and I doubt that you need bigger ones. All right, let's go with 2. 2 goes into 8 4 times, 2 goes into 12 6 times. Will 2 go into either one? It doesn't have to be both, but yes. 2 goes into 4 2 times, 2 goes into 6 3 times. Will 2 go into either one? Yes. 2 goes in there once. It doesn't go into 3, but that's okay. I bring the 3 down. Obviously, 2's not going to work anymore, but 3 will. Bring down the 1. 3 goes into 3 one time. Remember that all 1's down here means you're done. And the least common multiple is 2 times 2 times 2 times 3. 2 times 2 is 4, times 2 is 8, 8 times 3 is 24. Same answer, you pick the method. Now I've got 3 numbers. Okay, my process is the same. Method 1. I've got a 3 and a 5 and a 7, and 7 is the biggest, so I'm going with 7. I just go to the big one and start looking at its multiples. 7 times 1 is 7. Do 5 and 3 both go into 7? No, neither one does. 7 times 2 is 14. Do these go into 14? No. 7 times 3 is 21. Do those go in? No. 7 times 4 is 28. No. 7 times 5 is 35. Do those go in? No. This is getting to be a long process. How many multiples of 7 am I going to come up with? When that happens, I abandon this method and say, I really didn't like that very much. I'm going to try the other method. Now, I don't know if you're recognizing it, but the 3 numbers are prime numbers. So I can't divide any of them by 2, so I'll start with 3. It goes in there once, bring down the 5, and bring down the 7. Then I'll move on to 5, bring down the 1, goes into itself once, bring down the 7. Then I'll divide by 7, 1, 1, 1. That tells me I'm done. Your least common multiple is 3 times 5 times 7. Let's see what that will be. 3 times 5 is 15, and 15 times 7, let me do that. That's 35, carry the 3, that's 7, and 3 more makes 10. It is 105. See, I would not have liked to write down multiples of 7 all the way till I got to 105, but that's what I would have had to do. Back in these previous problems, I think maybe method 1 was the faster, but in this one, method 2 was the better. If I don't find a common multiple in the first, say, 4 or 5, I automatically go to method 2. And sometimes I just say, oh, these are big numbers. I'm not sure I want to use them in the listing of the multiples, so I'm going to choose automatically method 2. So I have 9, 75, and 15. Remember, my prime numbers are 2, 3, 5, 7, 11, so on. So 2 is not going to work in any of those. 3 will. 3 goes into 9 3 times. 3 goes into 75. Okay, let's see. It goes in there 25 times. And 3 goes into 15 5 times. Does 3 still go into any of those? Yes. 3 goes into itself once. It doesn't go into 25, and it doesn't go into 5. It only has to go into one of them. But I'm done with 3. So now it's time for 5. 5, I'll just bring down the 1. 5 goes into 25 5 times. 5 goes into itself once. Can I use 5 another time? And the answer is yes. Bring down the 1, goes in there once, bring down the 1. This means I'm done. My least common multiple is 3 times 3 times 5 times 5. 3 times 3 is 9. 5 times 5 is 25. So 25 times 9, 45, carry the 4. That's 18, and 4 is 22. The least common multiple is 225. So this method 2 is really good, especially for sets of 3 numbers. Number 6, I have 13 and 52. Well, I've only got 2 numbers. I'll just try method 1. Start with the big number, 52. Well, the first multiple of 52 is 52. Does 13 go into it? Well, maybe you know and maybe you don't know. So let's see. I'm going to guess 4 times. 4 times 3 is 12. Carry the 1. 4 times 1 is 4. Plus 1, 52. Yes, 13 does go into 52. 52 is the least common multiple. Remember, go to the big one. It might be the least common multiple. All right, we have one more. I don't want to look at a bunch of multiples of these because I know 15 is not going to go into 16. So I'm going to use my method 2. You always have the choice. So 15 and 16. Remember, my primes are 2, 3, 5, 7, 11, and so on. Does 2 go into either one? Yes. It doesn't go into 15, but it goes into 16 8 times. Will 2 still work? Yes. It doesn't go into 15, but it goes in there 4 times. Will 2 still work? Yes. Doesn't go into 15, but it goes in there 2 times. Will 2 still work? Yes. Doesn't go into 15, but it goes in there 1 time. My goodness, we're done with 2 finally. Does 3 work? Yes. 3 goes into 15 5 times, and bring down the 1. 3 doesn't work anymore. Let's try 5. Of course, 5 goes into itself, and bring down the 1. We're done. This is going to represent my least common multiple. It's 2 times 2 times 2 times 2 times 3 times 5 is my least common multiple. I know that's a 4, and I know that's a 4, and I know together that's a 16. 4 times 4 is 16. I know that 3 times 5 is 15. Oh my goodness, all I had to do was multiply the 2 numbers, but I didn't know that to start with. 5 times 6 is 30, carry the 3. 5 times 1 is 5, plus 3 is 80. Placeholder 0, 1 times 6 is 6, 1 times 1 is 1. That's a 0, that's 14, carry the 1, 240. The least common multiple is 240. Now I could have done this differently. I could have said 2 times 2 is 4, times 2 is 8, times 2 is 16, times 3 is, I think, 48, and 48 times 5, that's 40, carry the 4, 20, and 4 makes 24. Different I went strictly from left to right, and I got the same answer. Least common multiple is 240. In the future, you're probably going to pick one of these two methods when you're finding a common denominator. Going all the way back up to the top, you can do it by listing multiples of the big one till you get one that everything goes into, or prime factorization, and I encourage you to use this little shortcut if you go prime factorization.